Hello! Today I want to talk about the holy grail of GPS operation, taking questionable shots under extremely high canopy in really bad GNSS conditions. I have recently found out that SurvCE has a very effective GNSS analysis tool built into it, and it automatically does this process. In addition, if you use the built-in function, you can observe a point easily multiple times with intervene point observations. So you can look at point number 1, store point number 2, store point number 3, go back to 1, go back to 2, go back to 3, doing 10 occupations of each point if they're nearby each other. And then you can come back to your office, micromanage the GNSS analysis, and because this method utilizes the ECEF vectors and the variance and covariance between the rover and the base, and because it automatically throws out bad fixes, this procedure's been in SurvCE since at least version 3 in 2013, so it's not new, it's just new to me. Before we head out to take some measurements, we need to make couple of settings in our data collector. And I just wanted to show you that in the version 6 SurvCE user manual on page 413, there's a very detailed description of this function. Let's make a couple of settings here inside the office. The first thing we want to do is go to the hard hat in the upper left corner and click on Advanced Settings. And then click on the third item, GPS point averaging. We're going to do GNSS analysis. So see, you can do this from the coordinates, from the raw file, or from GNSS analysis. We're going to use GNSS analysis. We're going to do it when the IDs match, and we're going to use the 2017 method. I'll click the green check mark here. Go back, we're going to go to File, Job Settings, and then Options. And we want to make sure that timestamp each point is checked, store GPS accuracy in raw file is checked, and store GPS vectors in raw file is checked. The other thing that we want to do is go to Equipment and then Configure. We want to check this third line, Prompt for Height and Description. So those are the changes. Let's head out in front of the office and we'll collect a point under a tree. Connect to this head. Let me check the level on this head. We're going to go to Survey, Store Points, and we'll store point number 1. I'm going to take a 5-second average, and we'll store that point. I've got average same point ID checked. You'll see what this does in a second. You can also uncheck it, but you'll need to manually override a duplicate point. So we'll store the first observation of the first point. Okay, now I'm going to take the receiver and I'm going to dump the receiver and we'll wait for it to fix again. Okay, we're going to store another observation of point number 1. Looks great. Remember, I've got average same point ID checked, and this is a duplicate point. This menu comes up. I'm going to uncheck antenna freehand. And we'll click on the green check mark. We'll dump the receiver again and wait for it to fix. Let's store this point. This will be the third observation of point number 1. And you start to accumulate some information here. We're going to automatically check for letters in the vertical and letters in the height. It's pretty tight for being where we're at. Let's store this point. Dump the receiver again. Wait for a fix. And we'll store this as a repeat observation of point number 1. Repeat that operation. Now, I'm going to store a point over here. Obviously, this is a blunder. We're going to store this as point ID 1. We're simulating a bad fix. I think if I stand out here all day long, I don't think I'll get a bad fix in this location. I'm going to store that. This is the 6th observation of point ID 1. We'll dump the receiver and wait for the 7th fix. That was good. I'll store another observation. Leaves the 7th observation of point number 1. Dump the receiver again. Get another fix. This is the 8th observation. Dump the receiver again. Okay, dump the receiver again. Okay, so we've got 10 shots now. One of them is a simulated bad fix. Let's shoot another shot that's just slightly in air. We'll store that 10th shot. So I'm down half a foot over a couple tenths, and we'll store this as a repeat shot of number 1. Okay, we have 11 observations. We'll go back in the office and we'll take a look at the results from this operation. Okay, we collected 11 points out in front of the office. It went pretty well. Let's go and let's see what we got. On our point list, collected 11 points, but there's only 1 point. The 11 occupations with all of the averaging information is in the raw file. So the raw file has, if you want to go in and look and see what you did in a raw sense, you can use the raw file. But we only have 1 point in our CRD file, which I actually think is the right answer because it is only 1 point. Let's go look at that observation. We can do that under COGO and then point average. So let's give it a point ID. The point that we stored was point number 1. When we do that, it's going to read through the raw file and look for all of the observations of point number 1. You'll see they're numbered here. And it's going to automatically go through those observations. And you see the 6th observation here, it has marked, it's crossed it out, and it's marked it as unused for horizontal and for vertical, because both the horizontal and vertical were blundered. So point number 6 is not going to be used in this analysis. Let's go down to point number 11. It's been marked out also. And point number 11, the horizontal and the vertical has been marked off. And so based on this series of 9 observations, which were good, and that 9 is up here, it has calculated a location, which is enumerated up here. When you look at this, you need to realize this is all done off of the ECEF vectors. These are meters down below, so the northern, easting, and elevation are in metric. And then the result, because my job is in US survey feet, the result is in survey feet. Let's first store a report. Click on that, and this is a good name. We'll overwrite it. I'm just going to process point number 1. It's the only one in the job. And then let me go pull that job off the data collector and we'll take a look at it. Okay, I've got the report. Let's go up to the top and you'll see the report includes the job name, the receiver type, the RTK method, the version of SurvCE that's generating it. In this case, I'm using ellipsoidal heights. It also gives you the observation period, the first and last, and you'll see down here on this column, it tells you the delay. So the second point was 57 seconds after the first point. Then I waited 51 seconds, 52. This delay is important. The people who wrote this want you to occupy a point multiple times over a very long period. So morning, afternoon, next day morning, next day afternoon. I don't think that waiting that long is necessarily required. And the reason is that satellites are moving through the sky pretty quickly. And the thing that's keeping us from getting a good solution is not the satellites or their position. It's the trees or the canyon that we're standing in. So if we could move out in the open, we would need to do this because there's no chance our receiver would get a bad fix. Because the satellites are moving so quickly through the sky, I think it's reasonable to assume that a 5 or a 10 or a 20-minute observation period is pretty good. And to that end, in this case, we're standing under a huge tree just north of a very thick trunk, and we got 9 out of 11 observations that were good, and the 2 that were blundered, I manually blundered by holding the receiver in the wrong location. So, after the least square adjustment, we get the maximum horizontal. Now this MDB is minimal detectable blunder. So the maximum was 1.7 centimeters, and that was at observation number 1. And then for the vertical, 1.2 centimeters, and that was at observation number 4. Antenna freehand is off, so the statistical analysis, if you're doing a freehand measurement, not on a tripod or a bipod, is different than if you're on a tripod. And then for each occupation, we get the northing, easting, and height in meters, the antenna height, the fixed status, and then we get the residuals from the final mean, and then we get this minimum detectable blunder for both horizontal and vertical, the number of satellites, and the date and the delays. At the very end, we have the calculated point in survey feet and height, the number of observations that were used, and then statistically, I believe this is a 1 sigma estimate of error, in this case, in feet. So statistically, we feel that we're getting a 100th by 100th measurement on a point under a big tree next to a building. That's not bad. You've made it to the end of another extremely boring video on YouTube. If you have any questions or comments, you're welcome to leave them below. Hopefully I'll find them. You can send me email too. If you want to see more boring videos like this one, you can push the subscribe button down below or click on the little bell and you'll get a notice somehow from YouTube when I make videos. I don't make a lot. If you have ideas for future videos, please send them to me. Thank you again. Have a great day.